Hello, everyone. In CSC-121, we're starting a new module, Module 6, on databases. This is where we get into doing some business-type programming. So this is a 3-week module. So most of our modules henceforth have been 2-week modules. This one is 3 weeks long. There are a lot of different kinds of SQL databases that could be used. Some of the heavier duty ones are SQL Server by Microsoft, and Oracle is another very popular business database. Both of those typically require some sort of server, and they're operating system specific. And since we're doing this class so that it could be run on a Mac as well as Windows as well as Linux, we're using a cross-platform database, something that will work everywhere, and that is SQLite. SQLite. So, a little bit about SQLite, and you can read more on it. But SQLite is used quite a bit for mobile devices, to do a mobile device database, such as something on like an iPhone or an Android phone. It is a lightweight database, but it does probably 80% of what the full-blown SQL Server and Oracle databases do. So it's a nice lightweight database. When we say it's lightweight, though, that means that basically the SQLite database is just the database. It doesn't have any sort of tools built in to work with it. So if you want to, say, get into some sort of a management console to work with the tables and databases in there, then you would need a separate tool to do that. And so in the class out here, I have some links. Probably the easiest one to use is this DB browser. That's a graphical tool, where these other tools that you see here where it says command line tools, those are designed to run at the command prompt, and they're not as friendly of a type tool as this DB browser. So hopefully, since you're taking the Advanced Python class, you have perhaps taken a database class somewhere. At RCCC, our database classes are DBA 110 and DBA 120. And the 120 class focuses on SQL, and I think last I heard they were still using SQL Server in there. And in DBA 110, they were using the desktop database access, I think was last I heard. So about what SQL is, I've given you a link if you haven't been exposed at all to SQL. SQL stands for Structured Query Language, and as you can see, I clicked the link here to W3 Schools, and it tells you a little bit about SQL, and it's been around a long time. As you can see, it mentions that there was a standard by the ANSI that was released in 1986, and I actually have a book that I purchased that was published by Q on my bookshelf right now, and the markers that I was using for the pages in that book are punch cards. So that gives you an idea of how far back SQL goes. And so it's a very English-like language. It lets you retrieve data, update data, and in databases. They don't really come right out and say it here in the W3 Schools material, but SQL is kind of interesting because it's both a DML, which stands for data manipulation language, and a DDL, that's a data definition language. What I mean by that is some data definition things that you could do would be to create a database. So you can literally write SQL statements to create tables. You can write SQL statements to drop tables. You can write SQL statements to define relationships between tables. So those are all data definition language things. DML, on the other hand, is data manipulation, and that would be things like executing queries against a database, retrieving data from a database, inserting rows or records in a database. So you can see that SQL is pretty powerful, and it's very easy to use. Here's an example on W3 Schools of pulling back all the columns from the customers table in a database. So then they give you an example here. The customers table might have columns in it for the customer ID, customer name, contact name, address, city, postal code, and so on. And so you might have a row in the customers table for each customer. So and each customer would have their own name and address and city and so on. So I will leave that to you to look through this material on SQL. We're going to use it to interact with our SQLite databases. But the cool thing about SQL is it's mostly the same whether you're using an SQLite database, whether you're using a Microsoft Access database, whether you're using an SQL Server database or Oracle database. So the SQL is pretty much the same. So that's a cool thing about using SQL. So I'm gonna go ahead and show you this DB browser tool that lets us interact with SQLite database. Now, one difference with SQLite databases as opposed to SQL Server or Oracle is we don't have any security in SQLite databases. What I mean by that is in SQL Server and in Oracle, you have to create a user in the database and give that user permissions to do things in the database. With SQLite, since we don't have users, we obviously don't have permissions, because if we don't have any users, we can't grant permissions to anybody. So everybody has permission to everything. And so that's fine for what we're doing here, because we're not teaching you to be a database administrator and how to grant permissions and so on. We're teaching you how to get to the information in these databases. Okay? Now, if you've taken Microsoft Access, you know that Microsoft Access database ends, and if you're using the newer versions of Microsoft Access, that database file out there on your flash drive or on your hard drive ends in a .accdb. Back in the old days, they used to be MDB files. With SQLite, the database ends in .db, so as in database. So your SQLite databases will have a .db on the end of them. So I've already downloaded this DB browser to my Windows machine that I've got running here in a window on Linux. So I'm going to pop over there and show you a little bit about DB browser so that you'll see us use it to check to make sure things work correctly and so on. So I'm going to pop over to the Windows machine here, and so let me go back for a second. So this DB browser, you notice it says it's a portable version. That means that once you extract this zip file, if you're running Windows, you've got everything you need right there. You don't have to install it. You can run it straight out of the folder where it extracts. Okay? No installation necessary. And that means that you could take your flash drive, if you save this to your flash drive in a folder somewhere, you could take it to a computer in a classroom or the library or whatever, and if it was a Windows computer, you could double click on the file that I'm fixing to show you and you could run it. So that's what I mean by a portable app. We like portable apps because we don't have to have any permissions to install them. When we don't have to install them, we can just take them with us. So portable apps, real neat. Okay, back to Windows. So I've already downloaded that, and I'll show you where I downloaded it to my downloads here. Okay, here's my downloads folder, and you'll notice there's a zipper right there on the little folder. That's the zip file, and I extracted that. You know, just you can right click on it and say extract all, or you can double click on it and then hit the extract all button. But once you've got it extracted wherever you tell it to extract, then you have a folder out there on your computer that has that database DB browser in it. So let's see if we can find that folder out here. Let me get to my downloads. These are DB browser for SQLite is where I extracted it. So you could have this folder on your flash drive or wherever. You see it's got a bunch of DLLs in there. That stands for Dynamic Link Libraries, but the version that we're going to run is right here where it says DB browser for SQLite. Now you'll notice that there's a version for SQL Cipher. Let me explain why we've got two versions here. Remember I told you that SQLite doesn't have any users and therefore it doesn't have any security in the database. So if you wanted to protect your database such that somebody couldn't download your database, say you were using an SQLite program on a web server or something and you're worried about somebody downloading your database and getting to stuff, well, you can actually encrypt a SQLite database, and once it's encrypted you have to use this SQL Cipher program to get to it. So we haven't encrypted our database, so we can just use the plain old DB browser to get to it. So I have already created a database. There are 2 videos out there where you create this database first. In the first video, you create the database, you create the tables. The second video, you insert rows into the tables. So I'm going to open this up and let you see what it looks like here. Eventually. There it is. Now we haven't opened a database yet, so if I go to File and Open Database, I can browse for a database. Now I have actually run that program creating those videos and created this database, Python SQLite.db. Remember I told you that the database files ended in .db? Okay, so we're going to open that up, and you can see that it has 2 tables. It has 2 tables in that database, projects and task. Okay, and we can actually browse the data in those, and you can see right here that these are the columns in that database. Okay, and there's a name. This is, I'm looking right now, I'm looking at the projects table, and we've created one project in there that has a begin date and an end date, and it's got a row, or excuse me, a project name that's titled Cool App with SQLite and Python. So if you click on the task table, you can see it's got 2 tasks that are associated with that project. There's a project ID right there. And so this project ID column is called a foreign key because it references another column in a project table. So each one of these projects, or excuse me, each one of these tasks is associated with project ID 1. And if we go look in the projects table, you see where it's got ID 1. That's our one project that they're associated with. You can actually write SQL statements here in SQL Browser or DB Browser if you wanted to try things out. So, for instance, if I wanted to see all the rows in the task table, I could do a select star says give me every column in the table, and I say from, and the table name that I want to select the rows from is the task table. And when I hit the little play button right here, execute, you can see that I selected the 2 rows out of the task table. And because I said star here, I get every single column in those in that table. So that's a little bit about DB Browser. Now, with these SQL statements, we could actually insert rows, add additional rows to this table. We could delete rows from the table. We could update rows in the table. And we could actually drop the whole table. We could get rid of this projects table, which would be a bad thing, but we could do that in SQL. And the way we build these programs is we actually will just make a string that we passed to a query object. So we create a string that has our SQL in it, a string variable, and we pass that to the query object and then execute the query. So a lot of what we're doing here when we're working with databases is building these strings to run our queries against the database. So that's the DB Browser program. You can see how I selected the rows out. One other thing I was going to show you in here. We can go back and open that again. Let's see, we've got a file in there. Okay, one other thing I was going to show you in here is after you've created something, you can right click on it and if you go to modify table, you see it actually shows you the SQL that's required to create that table. This is an SQL statement right here to create a table named projects with these column IDs in it. Okay, so that's just showing you the way the DB browser can let you look around in the database. Okay, so we need to talk a little bit about security, because a lot of programming classes don't talk about security, and in this day and time, I would be remiss if I didn't tell you about some security issues when you're writing programs to use SQL databases. And so let me go to the material that I want to talk about here, and it's in the folder for Module 6. And if you come down, it's talking about right here, read the definition of SQL injection. And we've got a short program here to check this out. So SQL injection is, I'm sure you've been to a website where it asks you to type in your username or type in the something that you want to search for. Well, behind the scenes, most of those sites are actually building SQL statements and taking what you typed into that, that line edit in Qt, or that text box in Visual Basic or whatever. They're taking that and they're using that to build a query to run against the database. So if we click on this link to Wikipedia, you can see that it is a code injection technique. Now, I have actually taught seminars on IT security. I have my CISSP certification. And I've actually, when I got to teaching about SQL, I've had people get up and say they had to go back to the office to fix stuff because so many company applications, even now, are wide open to this. They just folks haven't been taught that this is an issue. And so that's why when I start teaching databases, I really want to talk to folks about SQL injection. So you can read more there in that Wikipedia article. But here's a little Python program that I created to kind of show you what could happen with SQL injection. And so I'm going to go to my downloads folder and see if I've got that program already downloaded here. Let's see. Preventing SQL injection. There it is. We'll open it with Tawny. And here it is. And so here I'm just, if you'll notice, I'm using a Python input statement, and I'm asking you to key in a programming language name. Okay? And I'm capturing that programming language name in platform, a variable platform. And most, do you remember when I was talking earlier and I wanted to select the rows from the task table? This is a SQL statement where we might select all the rows from our platforms table where the language is equal to whatever we keyed in here to that input statement. Okay? So let's first, if you'll notice in the comments, Ruby is a web programming language. We could try Ruby or we could try Python. It doesn't matter what you type in here. But let's run this program first, and let's see what gets built here when we do this string formatting with platform. And this is a good way of preventing SQL injection. It's not perfect, but it's a pretty good way. Okay, this is using F strings that are a newer, it's called a format string in Python 3.6 and above. And then this is doing it the way 90% of the folks that are writing apps right now do it. This is the bad way. So let's just do something normal here. We'll run this program and we'll type a programming language name in. Okay, so it says enter a programming language name. Well, we could type in Python. How's that? Now here's our first SQL statement, and you can see that it came from this line right here where it says we printed using string formatting, and we built a select statement that says select star from platforms where language equals Python. That's a perfect SQL statement. Okay, and here's another way of doing the same thing with an F string. F string's fairly new, been out about 2 years maybe. Okay, it takes less typing to do an F string than it does to do our string formatting. Okay, so here's an F string. We know it's an F string because they put the little F outside of the quotes. Okay, and this is filling in platform. It's doing some string formatting. What this dot and 12s says is use the first 12 characters, and that's all. Give me the first 12. That's all that I'm going to print out. If there's 30, we're only printing out the first 12. Okay, so same deal here. So when we ran this next one that says or the newest F string format, that's this output right here, and you'll notice that it built the same thing. You know, select star from platforms where language equals Python. And we were being good people, and we didn't type anything bad in. So the last one that is really vulnerable to SQL injection is this last one right here. Now so far everything looks good because we were being good little folks running the program. But now let's try something here. Instead of typing in something nice, I want you to notice what we're going to do now. Instead of typing in Python or Ruby, whatever, we typed in Ruby, and we put an extra quote in there, and we put a semicolon, which semicolon usually terminates an SQL statement. And then we added some SQL here to do a bad thing. We're actually going to delete the whole table called platforms. Thankfully, we're not hooked to a database here. If we were, we would be destroying data. Now, this injection's not limited to just destroying data. We could put an SQL statement here to say if we were, wanted to update the payroll and give ourselves a raise, we could say update payroll set salary equals to salary times 100% or whatever, 200%, where you're and actually update something here. Here we're just destroying it, but we could update something. So, okay, we'll be bad this time and key this in. So here we go again. Okay, it's asking us to enter a programming language name in, and if I paste that right there, and we can put Python, doesn't matter. This is Python, so we'll do that. You notice I typed in Python. I'm doing some SQL injection. I'm putting a quote here and a semicolon, and I've got some bad SQL. The programmer that wrote this didn't expect us to add SQL in. So watch what happens when I hit enter. Okay, here's our statement that we ran, and it would actually just throw an error in the database and not do anything bad because we limited it to 12 characters. There's no reason to have it wide open where somebody could key in as many characters as they wanted here. So we said limit them to 12 characters. So this is what gets run right here if we were using this as a query. Select star from platforms where language equals Python, semicolon, and then DRO is not even a valid SQL statement, so this would cause the query to fail and actually would be an invalid SQL statement. Okay, here's the same thing with the new F string. Again, we limited it to 12 characters. And you can see, because we limited it to 12, this is all that they're getting. Okay? But here's what happens if it's wide open. Select star from platforms where language equals Python. This is one SQL statement right here, and then it does the second SQL statement, which destroys the platforms table. So that's example little Python program. I talked you through how that could be, done to use to do SQL injection. So one of the ways that we can prevent, this is a little cartoon. I thought it was pretty neat. This mother's got her son's school on the phone and they said, we're having some computer problems. Oh dear, did he break something? And the person on the phone says, in a way. Did you really name your son Robert, quote, parenthesis, semicolon, drop table students? Oh yes, little Bobby Tables we call him. Well, the person on the phone says, well, we've just lost this year's student records. I hope you're happy. And the lady says, and I hope you've learned to sanitize your database inputs. So we were doing some sanitization of our input there with the string formatting. Okay? So there are other ways to prevent this from happening, okay? And one of them is to use something called a parameter query, where instead of making this string on the fly, concatenating everything together, this is a SQLite parameter query. It's got question marks in there for the placeholders. So we are telling the database that we've got this command here, and when we execute it, we're passing two parameters to it. So all that stuff that was quoted and all would have been, right here or here, and the query wouldn't work that way either. A lot of the approaches to security are doing what we call layered security. We just go ahead and assume that somebody's going to get by one layer that we've put in place one prevention. So we put it multiple ways. So in addition to using a parameter query, I might still use the F string, or I might have some code in there that, is there any reason for somebody to put a quote and a semicolon in where you're asking them to key somebody's name in? Is there any reason that somebody's name would have a parenthesis? So you could check and see if somebody's keyed that stuff in and get rid of it. Okay, so you can look for the type stuff that the folks are trying to do and sanitize it out that way. So one way to prevent, another way to prevent SQL injection is to use parameter queries, where instead of doing something like this, where we're building and using stuff to populate these things, okay, instead of doing that, we do this and set up placeholders. Okay, so that's a short. If anybody's in IT security that's taken this class, they probably have been taught a little bit about SQL injection. Maybe not a whole lot, but at least they know what it is. That's SQL injection. That's using the DB browser. I will tell you that in these upcoming lectures, and you'll hear me say this again, but in these two lectures here, here's a video, you'll notice that I used the PYQT5 approach. PYQT5 has a QSQL library, so there are two ways that we could have interacted with this database and created these tables. One way that's shown here is using SQLite. Right here, do you see what's being imported in the full program? Import SQLite. Okay, so this is using SQLite specific code to do this. I decided that I would show you how to do all this with Qt5 SQL code. And the reason I did that is because the QSQL module in PYQT5 is not specific to any database. So if you write it this way, that's shown right here, this is specific to SQLite. If you went back a year from now and said, well, I'd like to do this same thing, but I'd like to use Microsoft Access as a database, or I'd like to use SQL Server, or I'd like to use Oracle, then you've got to rewrite all this, because you're going to have to import something for Microsoft Access here, or you're going to have to import something for Oracle. If you use the technique that I'm showing you in this video, it works with any database. You may have to change your connection statement to have some security information in it if this database has security built in, but that's pretty much all that you have to change. So the code to do that with Qt is right here, okay? And you notice I put more flexible there because it will work with any database. So you've got a video here to get started to create the database and the tables that walks you through everything that I did here in this code. And then you've got a second video that is right here. After you've made the database, then you can go and watch this video and create a program to insert rows. And both of these use the QSQL module from PyQt5. Okay, so that's our first week of material in databases. There are the two videos on the checklist. This project 6 that has you creating the database and inserting 2 rows needs to be done this week, because there's a project 7 that has you using this database, and unless you do project 6 this week, you won't be able to do project 7 next week. So make sure that you get project 6 done this week so that you'll have a database that you can use to do project 7. Okay, good luck.